question. So it says we need to define a sequence of integers a valid if and only for all I from 1 to n. Ai is 0 to I. Okay, so just to keep up with the question, let's just write things down along the way. Um, yeah, so it is given that we need to define a sequence with length n, and the validity condition that we are given is that ai should be between 0 to I, which means like for the first position we can have value 0 to 1, for the second position we can have value 0 to 2, and so on. Let's move back to the question. Next it says that define the weight fa, okay, of a valid sequence. Initially a token is placed at each integer point in the closed segment 1 to n. So every index has a token initially. Perform n operation in sequence, which means 1, 2, 3, and 4, like in this sequence. During the ith operation, if ai is not equals to 0, remove a token in the closed segment ai to I. Okay, let's say if at fifth position we have ai equals to 3, which means we can remove one token from any of the positions starting from 3 to 5. That has not already been removed, obviously. Uh, so f is the number of ways to remove tokens. Two ways are considered different if at any position, if there exists a t such that positions of the token removed by the two different ways are different at the tth operation, which makes sense. Any operation, if the number of token removed or the position of the token removed is different, then the operations will be considered as different. We are given n and m. We need to find the sum of weights over all of the sequences, and there will be a total of n plus 1 factorial sequences, because at the first position we can have 0 and 1, and the second position we have 0 1 2, then 0 1 2 3, which means 2 into 3 into 4 into 5 till n plus 1. This is n plus 1 factorial total number of valid sequences, and for every sequences we'll have some value of fa. What is fa? Total number of ways to remove tokens. um, yeah, total number of ways of removing tokens, and two ways are considered different if at any position uh, the position of the token removed is different. Okay, that makes sense. So now let's look at the constraints. We can see that n is up to 5000. See, if n is up to 5000, it makes sense that n plus 1 factorial generating all of the valid sequences will not work. Otherwise, if that's n if this n was lower, let's say less than 10 or something, 10 into 9 into, yeah, less than 10 or something, then we could have generated all of the n plus 1 factorial sequences, and by using recursion, and we would have calculated all of the FAs, and then we would have added them. But no, obviously not. N plus 1 factorial doesn't make sense. Okay, so now let's move towards the solution and how I approached this problem. Okay, so initially we are given L, N, and M. This is my template. Okay, so see, let's start with smaller sequences. Let's say we have n equals to 1. So we can either remove 0 or 1 tokens, right? For 0, we will have one way. Okay, for 1, we will have one way. For 0, we'll have one way. How? Like we have n equals to 1, right? So to remove 0 tokens, don't remove any token, right? This is the only one way to remove 0 tokens. And to remove 1 token, remove the first token. This is the only way to remove the first token. Okay, and let's say for n equals to 2, let's say now we want to remove 0 tokens from a sequence with length 2. Don't remove any token. Again, one way. 0 tokens, one way. let's say one token. Now we can remove either the first token or the second token, right? So how many ways are possible? You don't have to count like either remove the first token or the second token. So there are two ways. No, that's not how it works. See why? What are the possible sequences? We can have 0, comma 1. These are for removing only one token, right? So using this, we can remove either the first token or second token. How? See, we have 1 at the second position, right? Which means we can remove a token starting from 1 to I, right? AI to I, which means we can either remove the first token or the second token. So here we have two ways to remove the first token. Now, one sequence is this, one way of removing one token. How? Just remove the first token. And for 0, we can't do anything. And second can be 0, comma 2. So this means that we can remove one token from the second position. So total, how many ways? This is one way and this is one way. So total number of ways is 4. Okay. See, we are removing either first or the second token only, right? But we still have 4 ways because for different sequences, we need to add all of the ways, right? Okay. So what I did here was I tried to create a DP with states I and j. Why? Because I was trying, let's say if I'm somehow able to find the answer for smaller numbers of n, so smaller values of n, then somehow I'll try to calculate the answer for the bigger values of n. Okay, so what I'm trying to do here is I'm trying to calculate the number of ways to remove j tokens till the ith position. Okay, according to this, dp of 1 comma 0 will be 1, dp of 1 comma 1 will be 2, dp of 2 comma 0 will be 1, dp of 2 comma 1 will be 4. See, is dp 1 comma 1 equals to, oh wait, this is 1. Is dp 1 comma 1 equals to 1 if n is greater than 1? Which means till the first position, the number of ways of removing one token, is it actually 1? No, because see, here also we are able to remove token from the first position. See, when we have sequences like 0, 1, we can remove token from the first position, right? Which means a great observation here is token, not great actually, it is very common and normal observation. Token at the ith index can be removed via positions greater than or equals to I, right? A token at the fifth position can be removed by index 7, right? Because 7 can have values 0 to 7, right? So it can remove any token starting from 0 to 7, which means any position I is able to remove tokens from any previous position. So higher positions have higher dominance. Position I cannot remove token from any higher position. Why? See, if the position fifth can only have values 0 to 5, so it cannot remove values from which are greater than 5, right? Because ai to I, the higher point is I. So I plus 1, I plus 2 doesn't make sense. So dp 1 comma 1 equals to 1 we cannot really calculate because we don't know yet how many positions are there ahead which will be able to remove this, right? As we are going from 1 2 3 till n, we don't know what's going to happen next, right? But we can come back from n to 1, right? And we know that when we are going back from n to 1, nothing is going to affect the answer. Let's say we start from n. Starting from n, we calculated answers. We know that n minus 1, n minus 2, n minus 3, they are not going to affect any answer of n, right? Because they cannot really change n. So we can go backwards, right? So the final dp uh, states that I assumed were dp I j, total number of ways of removing j tokens in the positions I to n. This is what I assumed, right? Let's say we are calculating dpn 0. So number of ways of removing 0 tokens from the nth position to the nth, like from the final position. This is one way. Don't remove anything. Now dp of n1, one way. Remove the nth, right? Remove the nth token. And now this is final. Nothing can change it, right? N minus 1 is not going to affect this. Okay. Now dp n minus 1 0. Again, do nothing, right? Remove nothing. And using this, we can try to calculate n minus 1 1, right? How? We know the total number of ways of removing 0 elements from the next position, right? At any position, if we want to remove x elements. Okay, now we already know the total number of ways of removing x minus 1 elements at the next position, right? If we are at currently fifth position, we are coming from backwards, right? So we already know what happened at the sixth position. Okay, so um, let's first define a dp. mm, n plus 2 vector ll. Why am I doing n plus 2? Because see, I wanted to start with n plus 1, which is the position after the final position. Why? I'll let you know. So dp n plus 1, we have already completed all of the positions. Selecting 0 ways, selecting 0 tokens will be one way. Select nothing. Okay. Now for int I equals to n, I is greater than equals to 0, I minus minus. For int j equals to 0, j is less than. See, what is the maximum number of token that can be removed from jth position? We can remove the jth token, the j plus 1th token till the nth token, right? So 5, let's say we have total n equals to 7 and we are currently at the fifth position. So we can remove 5, 6 and the 7th token. Okay. And previously only 6th and 7th token were removed. So in the previous dp state, we can only use n minus 6th and 7th, which means 7 minus 5, which is 2, right? N minus pos, sorry, I j plus plus. So this is the maximum number of tokens that were previously removed. So we can only do operations on this, right? Okay. So what I'm trying to say here is what dpi and j is denoting. Let's recall. It says total number of ways to remove j tokens from the positions I to n. Okay, and we already know this value. See, either we can choose to not remove any tokens here. Okay, which means dp of I j, we are not removing any tokens. Okay, so then this will be equivalent to dp of I plus 1 j. I think this makes sense. Or what we can do, we can remove one more token. Okay, which means this will become dp of I comma j plus 1. So now we will have to look at now we will have to look at the total number of ways of removing j tokens in the next position, right? So that ways were dp of I plus 1 j. Okay, and see how many positions can be responsible to remove a token from this particular index. From this particular index, all the positions starting from I to n can remove token from the ith index. Okay, so but some positions are already filled. Why? Because we have already removed j tokens, right? So those j tokens were removed by some of the previous positions, right? So we need to see how many positions are left. Let's say we are at fifth position and there are total 7 positions and one element is already removed, right? So how many positions are left? The current position and one of the next 2 positions, right? And one of the next 2 positions. So it is n minus current position plus 1 minus j, right? Yes, so n minus 1 n minus I plus 1 will give us total number of positions and minus the already removed positions. This will give us the position that are left. So these left positions will be responsible to remove the token from the current ith position. Okay, I know this is a bit overwhelming. You can listen it again. Also, how many values can it take so that the token at I can be removed? See, any value from 1 to I can be taken to remove the ith token, right? So values will be equals to I. All right. We need to do mod at every position. I j mod equals to m, and also we need to do a plus equals to here because we want to add these numbers, right? So maybe this thing is already filled and so we need to add this value. Okay, so all of these left elements can take these number of values. Okay, so total number of ways will be values into left. Okay, ways mod equals to m, and this will be plus equals to ways. Okay, I think this looks good. Now we will arrive at a position where we will have all the values from dp 10, dp 11 till dp 1n. Now simply we can add all of this, right? How many ways are there to remove 0 elements from 1 to n, 1 elements from 1 to n, 2 elements from 1 to n, till n elements from 1 to n, and this was our final answer. So answer starts from 0, 0, and answer plus equals to dp of 1 to I, answer mod equals to m, C out answer. Let's see if there is any mistakes. Mm, redeclaration of ways. Okay. Mm, are we using this anywhere? Oh, I missed one thing. So we have these many elements that are left. We have these many values that all of these elements can take, but also the ones that are already removed. There are many ways of those two, right? So those will also be, wait, let me rename this as total ways. Uh, ways. Let me explain this again. Mm, let's rename it as ways to remove j from next position. Okay. This is 131. dp ways were not declared. Total ways. This will also be updated. Mod equals to m. Mod equals to m. Okay. Fast. Let me explain this once more. See, we are at a position I. Okay. So we can remove either 0 elements or 1 or 2 or to the maximum, like the maximum elements that are possible, which is I plus 1, I plus 2 till n. How many these elements are? N minus I plus 1. These are the total number of ways that can be removed. But from the next position, only n minus I elements can be removed, right? And one additional element we'll try to remove in this transition. Okay. So what is the case number one? That either we can remove one, either we can not remove any element. So the ways to do this is the total number of ways that were in the previous position that were there to remove j tokens. Those will be added as it is. Or what we can choose to remove one more element, right? So we'll see how many ways were there to remove j elements in the previous position. Okay, now we want to remove one more element in the current position. Okay, so this current element can be removed by either the current index or the indexes that were left in the higher positions. So how many indexes were left? The total number of indexes minus total number of removed indexes, right? So this is the total number of removed indexes, this is total number of indexes. So these elements were left. So these elements can actually change the remove the token at the current position. How many values can these left indexes take? 1 to I. So this is the total number of values that they can take. So what will be the total number of ways to remove the current token? It is this into this into this. This is the total number of ways, right? And finally we arrive at this solution. So I know this was a bit complicated, especially to explain, but yeah, this was the solution. I think we can just go over it once more. See, we defined a DP which says dpij is equals to total number of ways of removing j tokens in position I to the last. Okay, so why? Because the greater indexes cannot be changed by the smaller indexes. Now, the base case is dpn plus 1 0, which means everything is ended and we haven't selected anything, right? Select nothing from nothing. There is one way. Okay. Now we'll start from the last position and we'll move towards the first position. I think we can go till 1 only. That is enough. Yeah. So yeah. So we'll start from the last position and we'll go from removals from 0 to n minus I. Okay. So these are the removals that are possible in the next positions, right? So these are the removals. Now what we can do is either we can choose to remove tokens or we can choose to not remove any tokens from the current position. So if we are not removing any tokens, then we'll copy the exact value from the next position. So like dpij is total number of ways to remove j tokens and we are not trying to remove any more tokens. So just go back to the next position and see how many ways were there to remove j tokens and copy them to the current dp values. And otherwise we can try to remove one more token. And what are the total number of ways to remove one more token? We'll see what are the positions that can remove the current token. So how can we check that? We'll see how many positions are left and how many tokens are already removed. The number of tokens that are already removed, those number of positions are not available, right? So total number of available positions are n minus I plus 1 minus the tokens already eaten. Okay, and what are the values that these tokens can take? It is from 1 to I. Okay, and from 1 to I, these are the total number of values. So total number of ways will be multiplication of these three. Total number of ways to remove j tokens from the next position, so those will be the total number of ways. Those will be there. Now how many positions are left? Any one of those positions can be used to delete the current token, and any all of these positions can take values from I 1 to I, right? So these 1 to I, which means I into left positions into total number of ways to remove j tokens from the next position. This will give us the value of how many ways are there to remove j plus 1 tokens starting from position I to n. And at last we'll add all of these values 1 to 0, 1 1, 1 2, 1 3 till 1 n, which means total number of ways of removing 0 elements from 1 to n, 1 elements from 1 to n, 2 elements from 1 to n, and so on. And this will give us our final answer. So yeah, so I know this question is not very intuitive. It is pretty complicated actually. So yeah, just think about it and try to solve it yourself. Take a pen or paper and see what's happening and try to write the code yourself. The implementation is not really that difficult, but yeah, overall the complex is a bit complex. So yeah, uh, okay.